Hello everyone. In today's lesson we're going to take a look at two different ways to perform limiting reactant calculations. So let's start with a chemical equation here today. Let's say we have sodium metal and it reacts with water. So this is going to be a single replacement reaction where the sodium metal is going to replace the hydrogen in water. We're going to form sodium hydroxide as one of our products, and then hydrogen gas as the other product. So we've got a single replacement reaction. We do need to balance this one. So we need 2 sodium, 2 H2O, and 2 NaOH. And that should be a balanced chemical equation for this single replacement reaction. So when we combine two particular amounts of chemical reactants, so in this reaction sodium metal and water, it's highly unlikely that we will have what we call stoichiometric amounts, where we use up all of both of those chemical reactants. More often than not, one of those reactants is going to be what we call the limiting reactant. That is, it will run out first. And then the other reactant, or reactants, if we have 3 or more, are referred to as excess reactants. So in chemistry class, we oftentimes have to determine which of our reactants is the limiting reactant. We'll be told for a particular chemical reaction the masses of each reactant that are combined, and we have to figure out which one runs out first. So, using this reaction as an example, let's say, hypothetically, that we combine 2.00 grams of sodium with 2.00 grams of water. So, highly unlikely that both of those amounts will be used up entirely in this chemical reaction. Highly unlikely that we have an exact stoichiometric ratio of sodium and water. More likely, one of those two reactants will be used up first, and then the other reactant will be left over. There will be some of it left after the reaction has run to completion. We call it an excess reactant, but we don't know which reactant is the limiting reactant and which reactant is the excess reactant just by looking at this chemical equation. Although you could figure it out, it's easier to go systematically approach this type of calculation to figure out which reactant is limiting. And there are two popular approaches to doing this type of limiting reactant calculation that I want to take a look at here today. So what we're going to do, we're going to create a new page here, so we can go back and reference that chemical reaction as needed. And we're going to take a look at what we're going to call method number 1. And we're going to refer to this as the have-need approach. So what we're going to do in this approach to determining limiting reactant is pick one of those two chemical reactants. It doesn't matter which one. Sodium is listed first, so let's go ahead and choose sodium and say I have 2.00 grams of sodium. And now the question that I want to answer is, if I am to use up all of that sodium, how much water will I need to react? So this is a basic mass-to-mass stoichiometry calculation. I'm going to first convert 2.00 grams of sodium to moles. So we'll multiply by the inverse molar mass of sodium. 1 mole of sodium over 22.99 grams of sodium. And then we're going to convert moles of sodium to moles of water. So I go back to my chemical equation. Coefficient for sodium is 2. Coefficient for water is 2. So this is a 2 to 2 mole ratio. I've got 2 moles of H2O for every 2 moles of sodium. So far I've canceled out grams of sodium, moles of sodium, I've got moles of water. And now I'm going to go ahead and convert moles of water to grams of water. So we'll multiply by the molar mass of H2O. So this will cancel out moles of H2O. And if I do the math, I'm going to calculate how much water will react completely with 2.00 grams of sodium. And this comes out to be 1.57 to 3 sig figs grams of H2O. So what I'm saying here is that if I have 2.00 grams of sodium, I will need 1.57 grams of H2O to react completely. So what I'm going to do is compare that mass of water to the mass that I have available, which is 2.00 grams. And what I find is that 1.57 is less than the amount of water available in this reaction. So what we need is less than what we have. And that means that the sodium is going to run out first. So because 2.00 grams of H2O, that's what we have, is greater than 1.57 grams of H2O, that's what we need, we can conclude that sodium is the limiting reactant. So that's one way that we can go about identifying the limiting reactant for a chemical reaction if we are given masses of both reactants. Now, at this point, we would still need to calculate how much product we need. If, for instance, we had been asked originally in the question how much sodium hydroxide will be produced, we would now need to use the 2.00 grams of sodium to figure out how much sodium hydroxide will be produced. So we can do that real quick just to show the stoichiometry. So we know that sodium is limiting. So to convert into a mass of sodium hydroxide, we're going to start with the limiting reactant, 2.00 grams of sodium. Convert to moles of sodium. And then we're going to convert to moles of sodium hydroxide. So it looks like it's going to be another 2-to-2 ratio here. And then convert to mass of sodium hydroxide. Molar mass of sodium hydroxide, about 40.00 grams per mole. So gram sodium cancel, moles sodium cancel, moles sodium hydroxide cancel. Do the math, get 3.48 grams of sodium hydroxide. If we had done this calculation with 2.00 grams of water, we would not get the right answer because we're not going to use all 2.00 grams of H2O. We're only going to use 1.57 grams of H2O. Should point out that if we had done the calculation with 1.57 grams of H2O, you would still get the right answer, barring any round-off differences. Should still come out to be about 3.48 grams of sodium hydroxide. Okay, so that's method number one for determining limiting reactant. And then we also show here how we can use the limiting reactant to calculate the mass of one of the products in our chemical reaction. So let's take a look at an alternative approach. Method number two. We're going to call this one which reactant makes less. Just our shorthand name for this second approach. This is an equally valid way to think about limiting reactant. What we're going to do with method number 2 is we're going to set up a stoichiometric calculation for each of the starting product masses. So 2.00 grams of sodium and 2.00 grams of H2O. And we're going to convert, using stoichiometry, each of those masses into the mass of one of the products of this chemical reaction. Now, it doesn't matter which one we use. We could calculate the mass of sodium hydroxide produced from each of the starting reactant masses, or we could calculate the mass of hydrogen from each of the starting reactant masses. It does not matter. But since we already did a calculation with sodium hydroxide in method 1, let's choose sodium hydroxide. So our first calculation is actually going to be identical to what we just did in the second part of method number 1, where we convert 2.00 grams of sodium into a mass of sodium hydroxide. So multiply by 1 mole sodium over 22.99 grams of sodium, 2 moles of sodium hydroxide over 2 moles of sodium, and then multiply by the molar mass of sodium hydroxide, 40.00 grams per mole. And remember that we came up with 3.48 grams of sodium hydroxide for our answer. So in method 2, we're going to do the same type of calculation, but starting with the other reactant, 2.00 grams of H2O. So we have to convert mass of H2O to moles of H2O. We'll multiply by the inverse molar mass of water. 1 mole H2O over 18.02 grams of H2O. Multiply by the mole ratio. It's a 2 to 2 mole ratio, still 2 moles of NaOH for every 2 moles of H2O. And then multiply by the molar mass of sodium hydroxide, 40.00 grams per mole. And we do the calculation. We come up with 4.44 grams of sodium hydroxide to 3 sig figs. So in this method, we've done 2 calculations, starting with each of the specific reactant masses to figure out how much of one of the products we would make if all of that reactant were used up. It's easy now to identify which reactant is the limiting reactant. Whichever of these calculations gives the lower mass of sodium hydroxide, that would be the 3.48. 3.48 is less than 4.44. That reactant is the limiting reactant. So we see that sodium is the limiting reactant using method 2, and that we're going to produce 3.48 grams of sodium hydroxide, the exact same answer we got with method number 1. So you're going to get the same answer either way. You have to use the method that you are more comfortable with. And these are just 2 of many different approaches for dealing with limiting reactant problems. So there are many other ways that you can go about this. Thinking about it in terms of mole ratios, for instance, can be helpful. This is just 2 unique approaches that are available to you.